In this segment, we're going to go over conversation programming, and because single point threading is one of the things that most people want to be able to do with a CNC lathe, we're going to go over that too. The MASSO software for threading is excellent. I would suggest if you're using a CAD/CAM software to generate your programs, you actually use the conversation program in this to generate the threading sequence, and then just cut and paste that into your main program. So what I did was, let me go to jog here so you can see. Okay, I changed out my 80-degree tool and put in a single point threading insert tool. Okay, so that's tool number 3. So the first thing I want to do is call up tool number 3 so my computer knows that's what I'm working with. So just T3, M6, enter, and it changes it to tool 3. Okay, on my tooling page, I go to tool number 3, it says thread, it shows that it's cutting on the front side, and I've already touched off the Z-axis and the X-axis on this tool. For the conversation program, you just click on F5 conversation. Up here you've got description, and I'm just gonna, this is 7/16 stock, so I'm gonna go 7 space 16 space 32. Okay, the date you can put in if you want. Output code is the code that you're going to use for your G code program. So we'll do the same one, 7 space 16 space 32. Common 7/16 threads are 14 and 20. I wanted to do a fine thread, so I just picked 32. So we've got an oddball size thread, but it's just to show the threading routine. So what I'm going to do, I could turn with one tool and thread with this one to speed it up. I'm just going to do my turning with my threading tool and then thread the part, just so you can see how the threading works on this. So we're going to go double click on one, and I've got my choice of OD turn, ID turn, face, drill, thread. So I'm going to go OD turn, select, okay, and you've got all your plug-in values. So for the first one, for the title, we're just going to go turn. For the tool number, it's going to be tool number 3. For the spindle speed up, this is milliseconds. I'm going to put in 2000. Spindle direction is always clockwise. Roughing RPMs. You can't go real fast threading because it's impossible for the feed rate to keep up. If I put in 2000 RPMs and it's a 32 pitch thread moving at 30 inches a minute, you'll exceed the ability of the machine. Okay, so there are limits to how fast you can turn. Your material obviously dictates your RPM. For the roughing RPMs, I'm going to put in 2000. Okay, finish RPMs, we'll leave it the same, 2000. I'm just doing a skim cut. Roughing feed rate, this is inches per minute. We'll go 5.0. Finish feed rate, 2.0. Okay, so the initial diameter of our stock is 7/16. So 0.4375. Tool clearance on the face, I'll say 50 thousandths. 0.05. Roughing depth of cut, I'm only going to clean up 10,000. So 0.01. Finish depth of cut, 0.002. Z finish depth of cut. This is if I'm going up against a shoulder, you don't want to leave 5 or 10 thousandths because you'll bury the insert. For the finish depth of cut, generally it's going to be 0.002, maybe 3 thousandths. 2 is pretty standard. My final diameter is going to be 0.4275. Make sure your numbers are correct when you look up here. The starting point is going to be 0.0 in the Z, and the finish point, this is sticking out about an inch, we'll just go in half an inch. So point, oh, got 2 decimal places. And it's got to be negative 0.5. I'm going to hit start. Then it wants to know what the wizard name is going to be, and we'll just go with a 7 space 16 space 32. Save. Okay. Generally, if it doesn't save it, oh, it did save it. Okay. Just so you know, if any name you put in here, if it doesn't save it, it generally means it doesn't like it. You've got an asterisk or something in there that it doesn't like, and you just have to change your output G code name. So we just turned it. I'm going to go to wizard number 2 for tool number 2, and we're going to go threading. Select. So the title, THRD, thread. Tool number, we're leaving it at tool number 3. Speed up delay, we'll stay with the 2000. Okay. Spindle is clockwise. The thread direction is right hand. You can do right hand or left hand. If you want to do left hand, you'll use the threading tool on the back side and come from the shoulder out to get your thread left-handed. The depth of cut, we're going to go 0.002. Oh, I missed my decimal point. 0.002. Spindle RPM. There's limits to how fast you can put your RPMs, mostly because if I'm turning, it's a 32 pitch thread, I'm turning basically 30 thousandths per revolution. The capability at 70 inches a minute of the stepper motor is going to be exceeded if I'm turning that RPM and that feed rate. For the most part, you're looking at RPMs of about 300 thousandths, 300. The pitch on this is 0.032. All right. We're going to get to the in-feed later. Right now, go up here. For my tool clearance, how far I want it to come away from the part after it does each pass, we'll go with 50 thousandths. 0.05. My initial diameter is what I just turned it to, so 0.4275. My final diameter, 32 pitch thread, is about 15 thousandths thread height, so 30 thousandths smaller than that. So we got 0.3, we'll go 390, we'll make it just a little bit deeper, 390 for my final thread. My lead length, it's good to have some lead in. It allows the RPM and the feed rate to get in sync with each other. Unless I'm trying to thread in someplace where I can't give it a decent lead length, I generally go with 100 thousandths or 200. We'll go 0.2. Okay, the Z start is going to be 0.0. The Z finish for the end, I threaded in I turned in ½ inch. So we'll go minus 0.45. Okay, so those are all my variables there. For the in-feed angle, you have your choice of 0 or 29. With 0, that means the threading tool is going in and cutting the same path each time. And on larger threads, that means that your threading insert is cutting on both sides of the threading insert as it's going through the material. The ideal way to do this is to have a compound on your machine that's kicked off at 30 degrees, and you'll move it in on the compound so that each pass, it's only the lead edge that is making the cut. So that's a lot less force on your threading tool, and you get a much cleaner thread. So what MASSO has done is they've got their software set up. So if I put in 29, what it will do is each pass, it will step in at a 30-degree angle for the next pass. So it's only the lead edge of my threading tool that's cutting with each successive pass. So I highly recommend just going with 29, and then we hit save. When you get all done, right now I've got turn and thread. We go save wizard, and that'll be the program file. That'll be the .wiz program. And then we go post G code. And it shows G code saved to 7.16.32.nc. So my conversation program's done. If I come here, generally from conversation, they'll load it to the bottom. If I have something wrong or I want to change something, I would call up the WIZ program, just hit load, and that just brings me back to my wizard. If I want to come in here and change a feed rate, RPM, depth of cut, any of that stuff. So I'm going to cancel this. I'm going to go back to load, and that's the .nc program is what I want to load. Okay, so it shows my turning and my threading. And you can see right here, it's kind of triangle shaped where it's actually coming in at 30 degrees for each successive pass as it does the threading cycle. So I've already tool-eyed this guy. I'm going to go to the F2 page, and it shows tool number 3, M6, change to tool number 3. Spindle speed of 2000. And actually, let's see if we can call this up and go to edit. So if I go through my program, okay, Z50 thousandths, Z427, Z minus ½ inch at 2 inches a minute, then it pops out. Then it's going to my threading cycle. So I've got speed of 300. It's going to Z.194, then X.425, and then it's feeding in with a G32 threading cycle minus 0.450 at 32 thousandths per rev. And those are all the threading cycles. So if that all looks good, I'm going to hit exit. Okay, so now I have to load the program again. I went into the edit mode, so now I'm going to hit this and hit load one more time. So it's loaded my program. I'm going to go to the program MDI screen. Whenever you run a program, if I run this program once and it's finished, I want to run it again, or from the start, you have to hit rewind first every time. You have a single block option, which I highly recommend. The single block works from the beginning until you turn it off. If I'm in single block and it goes through a couple cycles and it all looks good and I turn single block off, I can't go back in and turn it on again within that program unless I restart the program. So I'm going to start with single block. And another one, up here on your program page, it shows G code, which is what you're looking at now. Then you have overrides, and you have overrides for both your feed rate and your RPM. Your overrides for your feed rate do not exceed 100%. The overrides for your spindle go up to 150. So you can play around a little bit more with your spindle speed. If you want to reset it, hit reset, it goes back to 100. On this one to start, you might want to slow this down. Give yourself a little panic time to hit your feed hold button, or in extreme case, hit your E-stop button. So I'm going to go back to G code. We're on single block, and I'm going to start hitting cycle start. So my chuck is on. We're at 2,000 RPMs. Okay. Okay, so this is what I told you about. Right now it's going to Z of 50 thousandths. Okay, this should clear because this is sticking out further than this tool. Okay, however, I'm going to hit rewind and stop. It would be wise to jog this tool somewhere into the location first so we don't have any surprises with our adjacent tooling. So right now I'm going to go to jog. that has these tools out of the way so I don't have any surprises. Okay, I'm going to go back to my F2 MDI. So now I'm going to start stepping through the program. Rewind, I'm on single block. RPM's at 2,000, settling in. Z at 50. That's my finish pass, much slower. Okay, now it's going to start doing the threading pass. The RPMs go down to 300. And take it off single block. Okay, so we have a very nice thread. Each pass was right down the center of the thread. And we're looking pretty good. If I would check this with my mating part right now, if it was a hair larger, for just a little bit, you can just rerun the program again. The finished pass is going to just take a skim cut, you know, spring pass. If not, you can go to your tooling page. Okay, on your Z wear, you would just put like minus 1 thou, minus 2 thou, and then hit save, go back to your program, hit rewind, and you're ready to run again. So that's cutting threads. They come out pretty sweet. Again, I would use the 29 on your Conversation, and I would use the Conversation program as part of your main program if you're going to do threading on this. Earlier in the video, we showed the thread being cut, and we had a RPM of 300. Okay, some explanations here, and then we're going to show you how fast you really can thread it. At 300, we did that so you could actually see the cutter going through on each pass. At higher RPMs, it's just a blur. So the max feed rate for your stepper motors is 70 inches a minute, and stepper motors have higher torque at the lower RPMs and lower torque at the higher RPMs. So if you get up to the high end of the feed on the stepper motor, you're actually working at lower torque range. So you don't want to be really, you don't want to be close to the max on the stepper motor. Okay, so right now we're at 300. We're going to change it to 1500 RPM, and we're going to cut the same thread again. Okay, if you take the 1500 RPMs and you multiply it by the feed per rev, and on a 32 pitch thread that's 0.03125, it comes out at about 48 inches a minute. Okay, so at 70 max, 48, we're getting, we're 2/3 of the way to max RPM, or max feed rate on the stepper motor. So this is to show you what you can actually cut at as far as feeds and speeds, and an explanation of how you can calculate out whether you're going to max out your feed rate on your stepper motor or not. So I'm going to change it in the program, and then we'll cut this thread and you can check it out.